Welcome to the Voice of Autism Resource Hub. Our focus today is on a significant trend, the notable increase in autism diagnoses and the complex reasons behind it.
All right, today we're tackling a real medical puzzle, the huge spike in autism diagnoses. We're going to separate the facts from the fiction and uncover a pretty surprising technological twist that's changing just about everything we thought we knew. So, let's just get right to the heart of it. The big question on everyone's mind. Why are autism rates just skyrocketing? It feels like it's everywhere now, right? Well, the answer, it's probably not what you're expecting. I mean, just look at this graph. It's a hockey stick. The numbers have just shot up over the last few decades. And this isn't just a US thing. It's happening all over the developed world. So you have to ask, what on earth is going on here? And to put a real number on it, get this. Today in the US, it's about 1 in every 31 kids. 1 in 31. Just let that sink in. This isn't just some abstract number on a chart. This is a massive shift happening in our schools, in our communities, and it's forcing us to rethink how we see the human brain. Okay, so what gives? Well, the first big piece of the puzzle isn't some new epidemic. It's actually a story about the definition itself. It's like the goalposts have moved. To really get what's happening with the numbers, we first have to understand what we're even talking about when we say autism. And this is absolutely key. Autism isn't a disease, something with a single cause that you can cure. Not at all. It's a neurodevelopmental condition. Think of it more like a whole category of conditions, all defined by behaviors we can see. There's no one single thing to point to. And what's super interesting is how experts think about this now. We used to talk about a spectrum like it was a line, from a little autistic to very autistic. But that's not really it. It's much more like a wheel. You can see it here. Somebody might have huge challenges with social interaction, but be incredibly skilled in another area. Every single person has their own unique profile, their own combination of strengths and challenges. And this timeline, wow, it really shows you how much our thinking has evolved. The word autism first popped up way back in the 1910s, but it was just a description for some traits in schizophrenia. It took until 1980 for it to become its own official diagnosis. And then, just in 2013, the definition got even wider, grouping things like Asperger's syndrome into this one big category, autism spectrum disorder. So what does that all mean? It means a huge part of this rise is simply that we've gotten way better at seeing it. The net we're using to catch it is just so much wider. We're more aware, there's less stigma. We're finally diagnosing people who years ago would have just been called shy or weird or difficult and left to struggle. But, and this is a big but, that's not the whole story. Even when you factor in all those changes in diagnoses and awareness, there's still a real increase that can't be explained away. And to figure that out, we have to go deeper. We have to look at our own biology. And what the science is telling us is pretty clear. A whopping 80% of autism risk comes down to genetics. 80%. So for the most part, this is a story that starts with our DNA. This also helps explain something that confuses a lot of people. Why autism can just pop up in a family with no history of it. It's because of something called de novo mutations. It's just a fancy way of saying new mutations. We all have them. Tiny, random genetic typos that we didn't inherit from our parents. Most of the time, they do nothing. But if one of those typos happens to land in a really important gene for brain development, well, that can be a major factor in autism. Okay, so we know genes play a huge role. Awesome. But here's the problem. Knowing about the gene is one thing. Connecting that gene to a specific behavior is another. And to do that, you need really, really good ways to measure behavior. And that's where, honestly, we've hit a wall. Our tools are just old. Yeah, listen to this quote from Dr. Robert Schultz. He's one of the top researchers in the field. He says when it comes to measuring behavior, we're basically stuck in the 1950s. Think about that. Our genetics technology is in the 21st century, but how we measure the outcome, the behavior, is based on checklists and interviews that are decades old. And look how unreliable this is. It's kind of shocking. You get 2 expert clinicians to look at the same case, and they only agree on the diagnosis about 69% of the time. And even crazier, you give this same questionnaire to a mom and a dad about their own kid, and their answers barely overlap. The correlation is just 0.5. It means our tools are incredibly subjective and just not very good. Scientists have a term for this. They call autism a fuzzy construct, and that's a great way to put it. It's like trying to measure the exact size of a cloud. Where does it start? Where does it end? The boundaries are blurry, and our old subjective tools just can't pin it down with the kind of precision we need to match up with the super detailed genetic data we're getting. But what if there was a way to see what the human eye misses? What if we could measure that cloud precisely? Well, that's exactly what's happening right now, and it involves AI. We're talking about a genuine revolution in how we measure human behavior. This is where the story gets really, really cool. Just look at the difference here. The old way, subjective, slow, expensive, and you can't really do it on a large scale. The new way, using AI and computer vision, it's objective, it's fast, it's efficient, and you can scale it up massively. It is, no exaggeration, a total game changer. So how does this magic actually work? It's surprisingly simple, which is what makes it so powerful. You basically just record a 5-minute conversation. That's it. While that's happening, a computer vision system is analyzing hundreds of tiny facial movements, the tone of voice, all these little signals we'd never notice. And then a machine learning algorithm takes all that data and predicts a diagnosis. And the results? They're mind-blowing. After just 5 minutes of analyzing one person's movements, the AI is 80% accurate at predicting whether they have autism. 80% from 5 minutes of video. That's a level of precision that was just science fiction until very recently. But wait, it gets even better. Because social interaction isn't a solo sport, right? It's a dance between two people. So when the AI analyzes the interaction, the back and forth between two people, the accuracy jumps to a staggering 90%. It's not just looking at one person in a vacuum, it's measuring the actual social connection. Okay, so here's the ultimate test. The AI is hitting 90% accuracy. What about highly trained human experts watching the exact same videos? They come in at around 82%. Think about that. The AI, in 5 minutes, is already more accurate than a human expert. So what does this mean for the future? I mean, the possibilities are just huge. You could use this to bring expert-level diagnosis to people in remote areas just through a video call. We could finally start to untangle the differences between, say, autism and ADHD, and maybe most importantly, when we test a new therapy, we can now get a truly objective measurement of whether it's actually working. And this really brings us all the way back to the beginning. It's just like Dr. Schultz said, we have all this amazing, detailed genetic data, but it was being squandered because our behavioral data was so clumsy, so coarse. We were leaving so much on the table. This AI technology is finally the bridge. It connects our rich biological understanding with an equally rich, precise understanding of behavior. So we started this whole journey trying to solve a puzzle about rising autism rates. And where we've ended up is with a tool that gives us this incredible, almost unbelievable clarity. And it leaves you with a really big question, right? If we can now objectively measure something as subtle and complex as human social connection, what else about the mysteries of the human mind are we on the verge of understanding?
Therapy quiz. Q1. According to the speaker from the Autism Science Foundation, what is a significant problem with traditional methods of measuring human behavior, such as questionnaires and interviews? A. They are too new and have not yet been validated. B. They are only effective at measuring non-social, monadic behaviors. C. They have modest reliability with low agreement rates between different observers. D. They rely too heavily on advanced statistical modeling. Q2. The Be Smart video explains that the dramatic increase in autism diagnoses over the last decades is largely due to what factor? A. Changes in diagnostic practices and greater public awareness. B. a proven causal link between childhood vaccines and autism. C. The discovery of a single autism gene that is becoming more common. D. An increase in environmental toxins that directly cause autism. Q3. In the AI-based autism research presented, what is the key distinction between dyadic behaviors and monadic behaviors? A. Dyadic behaviors are seen in adults, while monadic behaviors are primarily seen in infants. B. Dyadic behaviors are repetitive, while monadic behaviors are related to social communication. C. Dyadic behaviors require a social interaction, while monadic behaviors do not. D. Dyadic behaviors are measured with computer vision, while monadic behaviors are measured with voice analysis. 4. What are de novo mutations in the context of autism genetics? A. Genes that are inherited from both parents and guarantee an autism diagnosis. B. Genetic markers that are activated by environmental factors after birth. C. New genetic mutations that appear in a child but were not inherited from their parents. D. A specific set of genes that only appear in fraternal twins.
Announcement. First course for special education teachers/specialized tutors/parents/interventionists who want to understand the 40-hour model plus 100 combos of evidence-based interventions from EBI/EBP, starting from 1/11/2025. Online and free. Online and free. Learners who know English, Japanese, Korean, please notify in advance. Subscribe to the channel to receive the link to the course link.